And finally, we can also use conditions when extracting or selecting data from matrices, just like with vectors. But it's a bit more complicated because we now have a second dimension. Now, let's say that we want to extract all days where we had a calorie intake over 1900. So, over the calories limit. Let's say that our limit is 1900 equals diet track. So since we want to extract the information about the whole day where we are above the calorie intake, we need to select all rows, so column operator, and we now have something a bit more complex. We have to again say diet track, and here we need to specify which values do we want to compare with our calorie intake limit. We want to compare the values from the calories row. This is the fourth row, so we want to compare all values from the fourth row. So we're going to say for column, so fourth row, all values from the row. Fourth row, all values from that row, and we want to compare all of these values if they are more than 1900. Like this, close bracket, and let's run it and see if it's going to work. Run. And there we have it. We have 2 days where we are above our calories intake limit. Now, let's say that we want to find the days where we are below our calorie intake limit. So, below the calories limit, that track. Now, let's say that we don't want to extract everything. We simply want to get the fats and the calories. We want third row and fourth row. Then we want to check the values from our calories row, from the fourth row again. So all values of that row. And we want to check if they are less than 1900. Let's run it. And we have only one such where this is happening, the first row, and we have only the fats and the calories for that row. Now, one thing that I want to show you here is if you want to extract different rows. So, what if you don't want to extract third to the fourth row, but you want to extract the second and the fourth row? You want to skip the first and the second. You can simply supply a vector of values. So, second row, fourth row. You are simply creating one mini vector here. Second and fourth row. When we run it, we get the carbs and the proteins. We get the fourth row and the second row that match our conditions. We can also use the find function to find the indexes where the values are matching our conditions. So below the calories limit v2. And now we're going to use find, and we're only going to supply the condition. So that track for column 1900. Let's run it. And we have only one value, the first column. Now, if I change this condition a bit, let's make it to 2000, we will get 1, 2, and 4. Now, the find function gives you the indexes of that fourth row where we have a match with our condition. Now, if I change this condition a bit and make it work on more than one row, it works in an interesting way, so be very careful with it. If I again make it work on the second and the fourth row, and let's change this condition a bit so that we can have less results, so 1900. MATLAB prefers to work in columns, which means that it will take basically with this selection that we did here, basically we gave it a 2x4 matrix. It will transform this matrix in one giant vector column. It will have its elements the following way: first, second, third, fourth, fifth, sixth, seventh, eighth. And if you look at these indexes, you will see that this is exactly correct. Now, the first element matches our condition. The second also matches it. The third also matches it. So we have 1, 2, and 3. The fourth element does not match it. So if you start counting by rows, the fourth element is 366. It's less than 1900, but we don't have it here if we count by rows. But if we count by columns, 1900 false. Next, the fifth element, 280, we have it. Sixth element, false, we don't have it. Seventh element, true, we have it. And eighth element, we don't have it. So, be careful when working with the find function on matrices. And finally, I want to show you how can you change values within a matrix. You would have probably already guessed that it's the same as with vectors. So diet track of all rows. Let's change our condition a bit. Let's say that we want to work on an inner submatrix. So not all rows. We want to work on rows 1 and 3. So let's work again with something a bit more scattered. So 1 and 3. And we want to check the columns for days 2 and 3. So that track of second row and columns 2 to 3 for that row. And we want to check if they are less than 290, like this. So we are taking the first and the third row of the diet track matrix. So this row and this row. And we are checking the diet matrix. We are checking the second row, this row, and we are checking that row from the second column to the third column. And we are checking them against this condition. So if this condition is correct, we should get these 4 values extracted. So as you notice, it doesn't really work as expected. It gives us the first and the second column instead of the second and the third column. It gives us the right values, it gives us the first and the third row, but not the values that we want. We want the values from the second and the third column. The way to fix this is a bit tricky and involves a couple of other steps. The first thing that we need to do is we actually need to select the whole row. So we are going to get all values from these rows that match our conditions. And we're going to save them in a variable. So let's say extracted row data. And now we need to extract our specific data. Like this, we need to say extracted row data. We know that the row data is this one here. So from here, we simply need to say, okay, get all rows for columns 2 and 3, like this. And if we run it, we get 140, 160, 65 and 68 exactly as we originally wanted. Now, why is this not working? This is not working because this condition here gives us the indexes of all elements in that row that match our conditions. Now, when we select the whole row, it gives us 1 1 1 0, which is true. So 1 1 1 0, this doesn't match the condition, but when it changes to second and third, it gives us 1 and 1, which will select the first 2 columns instead of the second and the third column. So this is why we need to take this one extra step. Now, whenever you are trying to extract data or something like this with such a complex, it's not really complex once you know what it is, but you can't really immediately understand what it does with a glance of an eye. So whenever you have such condition, whenever you're performing some kind of operation that looks even a tiny bit complex, well, the one thing that you can do is simplify it. And the way to simplify it is to extract your conditions into separate variables, to segmentize the code. The way that we are going to do this is we're going to create 2 variables that will determine which rows we want to take into which columns. So we're going to say calls to extract, calls short for columns, and we're going to assign our condition to that variable. And we're going to do the same thing with the rows. Rows to extract equals to this little tiny vector that we have here. And now all we have to do is simply give these newly created variables here like this, and everything will work the exact same way, but now it looks much more cleaner. Here you can clearly see, alright, we're clearly extracting some data. This is the name of our variable. We're extracting it from the diet track matrix, and we have rows, we have some rows that we're going to extract, and we have some columns that we want to extract. If we want to take a deeper look exactly what are these columns that we're going to extract and rows, we simply have to take a look at either the columns to extract or the rows to extract. And we can look at each piece of the puzzle individually. So it's a very good practice to simplify your code as much as you can. This will make your code more readable, more understandable, and of higher quality in general.